The current AI data ecosystem operates through raw extraction. Vast media libraries, like Darman Studio's 19.5 billion view catalog, are continuously scraped by machine agents without triggering any compensation. Traditional distribution was built for human attention. A user watches a video, a platform serves an ad, and the studio earns revenue. Machine ingestion bypasses the interface, stripping out the data and ignoring the ad unit entirely. This extraction process is highly inefficient. An AI agent pulling raw text and pixels from a standard web interface requires approximately 20 seconds to complete a single scrape. Optimizing for machine ingestion requires abandoning web scraping interfaces altogether. The data must be housed in a parallel, machine-native infrastructure. Studios cannot protect large-scale libraries by attempting to block AI scrapers. The traffic must be actively routed into an explicitly designed, frictionless transactional pipeline. The Metastamp v3 integration for Darman Studios offers a structural solution, converting those existing billions of views into an active, monetized dataset. The system operates through a bifurcated post-production pipeline. While the traditional file goes to YouTube or Facebook, a secondary automated path delivers the asset to machine audiences. Operationally, this new routing requires zero changes to the existing creative or editorial workflows. The output of this secondary pipeline is a structured data payload called a Pocket, which is delivered directly to AI companies via the Model Context Protocol, or MCP. By attaching an asynchronous protocol to the final master export, DMS delivers fully licensed, machine-readable data payloads to AI agents in under 30 milliseconds. The integration hooks into the exact end of the current workflow, occurring simultaneously with Step 4 of the DMS content pipeline. The protocol triggers asynchronously the moment the final master video file is exported. This document outlines the conditional routing logic. The upload service evaluates the asset for optimal ingestion. Assets under 10 megabytes route directly via the API. Heavy video files chunk into 500 megabyte segments, routing through pre-signed URLs for secure transfer. Alternatively, the URL processor service provides a failover method, allowing DMS to bypass heavy file uploads entirely by simply processing the published YouTube URL. This dynamic routing logic adapts the upload vector to the payload weight, guaranteeing zero disruption to the post-production timeline. New uploads only account for future revenue. Securing the massive historical catalog of thousands of pre-existing DMS videos requires processing without manual labor. Metastamp's engineering team executes a bulk ingestion process, beginning with channel mapping. The system utilizes the YouTube Data ATI version 3 to map the entire channel playlist. A custom automated script iterates through the channel sequentially, using cursors to capture every entry, extracting the video ID, title, description, thumbnails, total duration, and exact publish date. Simultaneously, the Transcript API automatically pulls the closed captions and complete transcript. Bulk ingestion operates as an automated data harvester, converting a disorganized web-hosted archive into a normalized repository ready for algorithmic formatting. The extracted text and metadata are compiled into a Pocket, a highly structured, machine-readable snapshot. To ensure unique identification, the asset undergoes multimodal fingerprinting. The visual layer uses cryptographic hashing. The audio layer undergoes spectral analysis for its frequency signature, while the text is compressed into dense semantic embeddings to map contextual meaning. Fully fingerprinted, the completed Pocket is registered into the Metastamp MongoDB database. This intensive multimodal processing is what elevates a standard video file into an indisputable, immutable digital asset marked with an active status on the server. Access is governed by the Model Context Protocol, or MCP, the open-source gateway created by Anthropic to connect AI agents to structured servers. Metastamp enforces an iTunes agreement model, where the legal licensing framework is hard-coded directly into the communication protocol itself. When an AI model discovers a Pocket via the registry, the agreement service intercepts the connection. The code is the contract. Connecting constitutes instant legal acceptance. Once accepted, the agent initiates the high-speed data pull. The backend utilizes a Redis cache lookup, locating the required Pocket snapshot in approximately 1 millisecond. The structured, legally licensed content is pushed directly from the secure server to the AI model in under 30 milliseconds. This programmatic legal handshake eliminates human lawyers, invoices, and manual negotiations entirely. That 30-millisecond delivery triggers a synchronous financial event. Every poll fires a log to the Metastamp metering service. This revenue table projects the economic impact. The integration uses configurable tiers, anchored by a base case rate of a quarter cent per data poll. Applying that fee to an estimated 16 billion annual AI touches generates $40 million in projected annual revenue. Earnings accumulate in real time within the Metastamp wallet model and settle to the studio accounts on a standard net 30 schedule. The financial viability of this architecture does not rely on massive individual licensing deals. It relies on capturing volume through friction-free microtransactions. Darman Studios is the flagship integration. Once proven, the protocol is designed to scale horizontally across 10,000 independent creators within the network. Onboarding is frictionless. Network members authenticate via a self-serve dashboard, paste their YouTube URLs, and trigger the bulk ingestion process automatically. This expansion consolidates 10,000 independent creator catalogs into a single, unified Metastamp registry. The resulting consolidation aggregates these individual channels into a single, unavoidable licensing block for AI companies. By aggregating their leverage under a single MCP server, the network dictates the physical terms of AI access, functioning exactly like ASCAP or BMI for the generative AI era.